Hello once again. So this time we are concerned about the continuity of a function on the real numbers given by the following rule. It says that f of x is equal to x squared minus 64 over x minus 8 if x is different from 8 and is 16 if x is equal to 8. So let's try to analyze the function and say, well, look, it's defined on the entire real line, and the pieces that it is made of are all continuous. So if you look at this and regard this one as simply a function on its own, this is a continuous function as is constant. If you regard this piece on its own and define a function wherever it is definable on the real numbers, then it is also a continuous function. But the problem is the following, right? We are mixing these two items together. So what we would like to see is whether the following takes place. We need to answer this question. For which values of x we have that the limit as x approaches, for which values of a? We need to find for which this actually takes place. In other words, for which the limiting process commutes with evaluation of the function. Now, if we examine the function carefully, the only place that we have to be careful is exactly at 8. That is the only possibility for which this function may not be continuous. So let's examine that. Note that we only need to worry in near 8. So what is it we're going to do? We're going to calculate a limit, right? First, what is the limit as x tends to 8 of f of x? Of course, this limit has to be taken close to 8, not exactly at 8, right? So it's a limiting process, we're approximating 8. But as we are approximating 8, well, we may use this formulation. So we may replace this limit with the following one. Again, the intended idea is that we are getting close to 8, but not exactly 8, so that we can make this replacement. Well, that's the intention. So now, some algebra. I'll take this limit as x goes to 8, 8 of x minus 8 times x plus 8, being this a difference of squares, and then this divided by x minus 8. Of course, I can do a cancellation here. I can simply eliminate these ones because I'm close to 8 but not equal to 8. So this number that I have here is different from 0, and this number that I have here is different from 0. So what results is the following. This is the limit as x goes to 8 of x plus 8. Now, this expression defines a continuous function. Again, I'm trying to replace an 8 by infinity. I'm sorry, but it's tilted, so what can I do? Okay, so this one being continuous, all that I have to do is evaluation. So this is 8 plus 8, which is 16. But recall that f evaluated at 8 is exactly 16. And now we discovered that the limit as x goes to 8 of f of x is 16, as we found here, as we computed here. So look, the limit and the value at that point coincide. So the function is continuous there. Well, but that's the only place that we had to worry. So f of x is continuous at each real number. That you may denote, or you may say, equivalently, f of x is continuous on the interval from negative infinity to infinity. Okay, I hope that you like it. Take care.